I'm Grace.
My name is Veli.
My name is Devyani Gadja.
So I'm Michael Macy.
I'm Mark Fox-Powell.
I am Dr. Rachel Happ.
I'm Julia Sempri.
I'm a final year PhD student.
And I'm a PhD student.
And I'm a PhD student.
I'm a postdoc.
I'm a research fellow.
And I'm a postdoc in planetary geochemistry.
I'm a research fellow in AstrobiologyOU at the Open University.
I chose astrobiology because I was always very interested in space, and I did a physics degree at the University of Edinburgh, and within that degree there was an astrobiology course, which I thought was really inspiring.
I was also very interested in DNA, RNA, the workings of a cell, so I did my degree in molecular biology. And accidentally, I found in a book this astrobiology discipline, and I realized that I can apply my background in biology and my love for biology in the search for life.
They put out a really exciting research proposal that I could work at the intersection of technology and society and examine their impacts.
I previously worked on microbes that live in soils and how they interact with different plants and affect the growth of the plants. And when this project came up, it was an opportunity to take those exact same skills, but instead apply them to a space context and work with some really, really cool samples.
Through studying biology, I just got really fascinated in what biology really is and why it exists on Earth and how common or rare it might be elsewhere. So I didn't really think I could do that at kind of PhD level, but when I started looking for PhDs, I found advertised astrobiology PhDs, which absolutely blew my mind. So I ended up following that route, and here we are.
So I was really interested in chemistry, and specifically chemistry of icy moons, and understanding what is going on in the internal structure of these moons. And in turn, that's kind of led me to leading whether or not that ocean chemistry on these icy moons could potentially be habitable, and what that means for life on these icy moons.
Actually, I started out studying rocks on Earth, and by accident, I decided it actually was interesting to look at rocks on other planets as well, and particularly how rocks could create environments where life could exist. And so that's my path to astrobiology.
So there are a lot of missions that are either launched or due to be launched, which are coming up, like Dragonfly, which is going to Titan, which is an icy moon of Saturn, and also JUICE, which is a European Space Agency mission going to the icy moons of Jupiter. So that's kind of something that I'm very excited for, because we're going to get loads of data back from these missions, which will tell us loads more about icy moons and kind of the conditions on them, and hopefully narrow down our search for life in our solar system.
So I think that the exploration of Mars is not over. We have a Mars sample return and a few other very interesting and exciting missions coming up. And I think hopefully we'll develop our instrumentation further to be able to do everything remotely and then bring samples back to Earth rather than going ourselves.
Astrobiology research will become more holistic. It's already becoming holistic. It's looking at a lot of different areas of society. And our research group is one of the first groups that's doing that. But hopefully, in the long term, this will merge to become a more normal thing that astrobiology encompasses all these areas.
I think some of the really cool missions that are going to come about in the next few years are going to be major turning points for the field. So there's Mars sample return. It's probably going to happen in the 2030s. That's also when we're going to see Dragonfly reaching Titan.
I think really the focus over the next few decades is going to be on really exploring our solar system. So we have a lot of exciting missions coming up that are already flying, and these are going to really expand our knowledge of our solar system. But also looking beyond our solar system, we're going to start looking at the distribution of possible habitable planets elsewhere in the galaxy. So I think really kind of populating, increasing the amount of data we have on potentially habitable worlds, both in our solar system and elsewhere.
I think the future of astrobiology is in icy moons. I may be biased to say because I love them, but there are multiple missions planning to go to these icy moons, specifically trying to understand the chemistry and what that means for life.
There are lots of exciting things that go on in astrobiology. We will have sample return for Mars, so I think there could be potential life still found on Mars. That is one thing that is interesting. There will be more efforts to understand icy moons, so I think this is an exciting time to hopefully understand these environments better and maybe potentially even understand exoplanets better now that we have the James Webb Telescope.
I think it's getting the data back from the missions that are due to be launched or the missions that are already up, and really beginning to narrow down what we're looking for in terms of habitability in our solar system, but also in the wider universe.
Definitely Mars sample return. I'm very excited to be doing my PhD now, so by the time my Mars sample return happens and the samples come back to Earth, I should be in a good position to maybe be part of the teams or apply to be part of the teams that analyze those samples.
I'm excited about the potential of astrobiology technologies to help solve society inequalities because they have a lot of potential. They can be used for disaster risk reduction, they can be used for healthcare. So I'm excited to see all of these things actually take place in the world.
Advances in sequencing technology, so our ability to look at what microbes are living in what environments and how they're surviving there, has come on in leaps and bounds in the last few years. Every year it gets massively better, and that means that we can better understand these extreme environments that are analogues for space. And 10 years from now, that's only going to be better.
I think for me, I'm really fascinated with our solar system and what it can tell us about other solar systems. So the kinds of missions that we have coming up and already flying, missions to the icy moons, sample return from Mars, we actually are at the cusp now of understanding whether life exists beyond Earth in our solar system. So I think that's what's exciting me the most, is answering that question. Is our solar system inhabited elsewhere or not? And either way will tell us something really important about the distribution of life in the universe.
I am excited about the missions that are going to be going to these icy moons and trying to understand the different organics and trying to detect prebiotic chemistry. And this is essentially evidence of kind of the first signs of chemistry and organic material that life needs to be able to get going.
New missions are always the most exciting part. We will get quite a few missions to the icy moons. They have not been studied that well, so it will be really exciting to get these going and then combine this with analog work on Earth and understand the extreme environments in which life could have happened.